Okay, welcome everyone to building a website in Swift. My name is Tanner. This is a very serious picture of me. I'm a software engineer. I've been programming for a little over 10 years. I studied at New York University, and these are the languages I know best, kind of in order of which ones I like the most. Obviously, Swift is at the front. So let's get into the topic for today. Let's build a website in Swift. So this is more, let's build a web app in Swift, because websites today have so many different components. They've got possibly cloud storage. They've got the web app itself. They've got iOS apps, Android apps. So building a static website in this day and age doesn't really happen anymore. And Swift is kind of being shaped to really handle the current environment for how websites look. So why Swift? Why are we programming in Swift? I'm sure everyone at the previous conferences today has been talking a lot about this, so I'll be brief, but Swift rules. You already know that, that's why you're here. Why does Swift rule? Well, these are some of my favorite reasons. It's got beautiful syntax, amazing speed, and modern features. But what does this mean for web development? Well, it means a smaller learning curve because of that beautiful syntax, fewer bugs, and more performance on less hardware. So this means you're going to be spending less time making your application and actually more time writing features, and you're going to spend less money hosting your application and get a lot more performance out of it. So why should I switch, you might be asking? Well, if you're an iOS engineer, Swift on the server gives you a chance to design your own backend. And this opens up a world of opportunity. Not only is it going to increase the quality of your applications if you're designing the front end and the back end, but you could do things that you couldn't do before because you have control over both of those. If you're a back end engineer, well, you're going to write better code and you're going to write it faster. And while you're writing this code in Swift, you're going to be learning the language that powers all of Apple's platforms. And that's going to open up opportunities for you in the future. So let's get into the code. So when I was deciding what to code today, I was thinking, well, you know, Swift and birds have a little bit of a relation. You guys might already know this, but the Swift logo is indeed a bird. It's a real bird that actually looks surprisingly like the logo. They did a really good job with that. So I figured let's do something related to birds. Ornithology is the study of birds. You might know it as bird watching. So this is what bird watchers look like. They've got some cool birds. They're hanging out in the wilderness. And I figured, you know, look at that lady. She's holding some paper and a pencil. That's so 2000. We need to make her an app. So let's do that. So let's do this Birdwatcher app. It's going to record bird sightings to the cloud. It's going to use Cornell's Ornithology Api to verify the birds and to get pictures of the birds. And we're going to use the Vapor Web Framework. A little bit about the Vapor Web Framework before we get started. These are some statistics about it. It was created in January, and it's basically gotten an amazing following so far on GitHub. Tons of commits, tons of stars, tons of code, and tons of awesomeness. But one of my favorite, what I think is the most impressive statistics so far, is that we're the most used Swift 3 package out there. And IBM calls Vapor the most essential Swift package. Other GitHub scrapers call us the most popular package. So I think that's really awesome. So let's get into it. And feel free to chat, write anything in the chat. I have this open up on a different screen, so I can try to answer questions as we go if anything's not clear. I just got done creating a new Vapor project using the Vapor CLI, so you can see you get this printout when you're done. I can show you a little bit about the Vapor CLI. These are the commands you can run. It can create new projects. It can build the projects for you. It can update itself, create Xcode projects. But what's really cool is it can create a Heroku project or a Docker project, and it's going to take care of initializing all of those settings files and doing all of that so that you can just directly push your stuff up to Heroku or Docker and get started really fast. And of course, down here is a link to our Slack. If you ever have any questions, we're always online there to help you out. Okay, so let's open up the Xcode project that I have. And I can kind of try to familiarize you with the folder structure here. So the app folder is where you're going to put all of your source code for one of these projects. You also have models and controllers and middleware, which you might have heard about, but we're going to go into what middleware is about as well. You also have configuration, public files, that's where your CSS and your images go, and resources, and those are where your views and view files, template files go. So let's just dive right into how you get started with your application. So all Swift 3 packages have a main.swift file, and this is the starting point for your package. So in here, we're going to type import Vapor, and then let me close this out so we have some more room. And now we're going to create what's called a Vapor droplet, and the droplet is a wrapper around all of the useful features that Vapor has. So the server, the router, the hasher, sessions, all of that is going to be included in this by default. And if you want to do something more custom, you don't have to create a droplet. You can actually go through and you could create a server yourself and you could do all of that. But the droplet kind of ties it all together and marries it in with configuration and makes it really easy to use. So that's what I'm going to show you today. So let's start out with hello world, since that's what everyone likes to see. So let's make, we're going to add onto the drop, when you get welcome, we're going to return hello world. So if you're familiar with Swift, you'll know this trailing closure syntax, but if you're a little new to Swift, that might throw you off. Well, all that's happening here is this is the function signature. We're putting in the path here, and we're putting in a closure, which takes a request and returns a response representable. Now you can see it's not returning a response, it's turning a response representable, which means that we can return anything that conforms to that. So string by default conforms to that, and you can make your own types conform to that too. So you can return them here, and they can convert to JSON, they can convert to XML, whatever you want. So the last step is to just call drop.serve. And I'm just going to show you the CLI first. We could run this in Xcode, but I want to take a chance to show you this. So once we've saved the file, we're going to run Vapor build. I'm going to go through, and that's going to compile the project. OK, there it is. And now we're going to run Vapor run serve, and that's going to serve our application. And you can see it's serving dev at localhost 8080. So let's open up a REST client here. OK, and let's copy in that localhost 8080, paste it in there, /welcome. And there we go, hello world, coming from Vapor 0.12. OK, so that was easy. Let's go in here and let's kill this server. OK, so now let's get started with our Birdwatcher app and kind of the first step to that. So I want something that, I want a RESTful resource called sightings, and these are going to be the times that we've seen one of these birds, and you're going to post the name of the bird. And it's going to just record what time you saw it at so that you can have that for your records. So I want it to look like post sightings, and I want you to be able to put the bird name in here. So if you saw a sparrow, you could put bird sparrow, and you could post that. So let's make this work. Let's delete the hello example here. OK. And now that we're using post, we're going to change the word here. So that was get previously. So we're going to do drop.post to sightings, and then we're going to open up this closure with the request. And now how do we get this name out of here, this bird name? Well, this is the request content here. So it's just as easy as calling let bird equals request.data bird. And now this could come back as any different type of thing. They could be sending a double, they could be sending a string, an integer. So we provide a really easy syntax for casting that to whatever type you want. You could do any of these, and one of those is string, which is what we're looking for here. Now, this is an optional, so we can use Swift's guard statements here to confirm that we got that optional. And if they don't send the bird name, then we're just going to throw an abort.bad request because we need that bird name to create a new sighting. Now, let's just return the bird name so we can see if it all works. Now, I'm not going to use the CLI. I'm just going to use Xcode. So I hit Command R. It's going to build. And just like that, you can see serving. There's a little bit of weird stuff here in Xcode because we provide those nice colors for the command line. So just ignore that. You can also disable that if you want. So let's head over to rested, post that, and you can see it's easy as that. It's returning sparrow. And if we uncheck bird, in a lot of web frameworks, what this would do is this would probably crash because you expected to get this, and it's going to give you some sort of an array out of bounds or key not available. But since Swift forced us to think about that when we typed it because it was an optional, we get great behavior right off the bat. But as you notice, we're returning just the string there. So let's make this JSON. That's also super easy to do. And let's just give this at key bird. Run that. Switch over to our client. And if we include that bird there, there we go. We've got some JSON coming back. OK, well, now we have the information coming in for our sighting, but let's make a model for it. So we can clean up some of this code. So let's head over to the models folder. I already created a sighting file for us. And let's import Vapor, and let's make a sighting. And what we want this to have is, well, we want it to have the bird name. So let's do that. And let's also record the time that we saw it at. So let's do that, and that'll be an integer. OK. Now let's give ourselves an init method here. We're going to accept a string and an int. You guys are probably used to this. And we're just going to set that there and set the time equal to the time and the bird equal to the bird there. OK, let's also give ourselves a convenience init method for just putting in the bird name that's going to do the current time. And that's using NSDate, so we can import Foundation. It's going to work just like it does in iOS. OK, so we've created the bird there. So now let's go back over to, or the sighting, sorry, and let's go back over here, and let's initialize one of those. So there's the bird name, and there we go. Now, wouldn't it be great if we could just say return sighting, and it would just automatically convert that to JSON and just return it for us? Well, if we make this conform to Vapor's model, we can. So let's add in model here. And it's going to tell us a couple of things that we need. And you can always come over here and see what it's asking. It's an ID. And that's going to be of type value, which is a database value. So some data stores will hold IDs as an integer. Some hold them as a string. Some hold them as data, like Mongo holds theirs as a hex string. So this comes in as a value. And we can just set this to nil when we initialize it ourselves, because obviously it's not in any sort of a data store yet. And the last thing that we need is to add this init method, which is going to create the sighting when it comes off of the database. So we expect that the ID will be at key ID if we're using MySQL, which we're going to be using today. The bird is going to be at key bird, and we are going to make that a string. It works just like the request data does. And if we don't get a string, then we're just going to set that to be empty, because we have a string here and not an optional. And we're going to do the same with the time. We're going to make that an int, and if we don't have one of those, we're going to set it to 0. So just like that, you can see the app is compiling now. And we're just returning citing here. We didn't have to write any of that code, but let's see how it works. So we come over here, we post it, and you can see there it is. It made the JSON for us. So the bird is a sparrow, and the time is this. And if we post, the time is changing. That's awesome. Well, now we need to save it to a database. So let's bring in MySQL. So let's go over to the main file. And let's import Vapor MySQL, which I've already included in this. It isn't included in Vapor by default because obviously not every project is going to want a MySQL database. But if you do want it, you just add it to your package and it brings it right in and you import it like this. Now, one of the great part about the droplets is they have this feature called providers. And what a provider does is it provides a consistent way to add functionality to your application. So anytime you're using a Vapor provider, you know that you can call the module name here followed by provider. And you can call the init method. And this is going to be whatever you need to give to that provider to make it work. So for the MySQL provider, obviously it needs a host and that various information. So I'm going to put this in. It's localhost running root. Password is empty. And the database is going to be called Birdwatcher. And now this is something that can fail. And you could catch this and log it accordingly. But since this is a demo, I'm just going to say crash the application if you fail. And all we do now is we just say droplet providers and we pass it MySQL. And to show you guys that it's working, I'm going to copy in this code here. And what this is going to do is this is going to take the drops database and cast it as a MySQL driver, and it's going to try to select the version from that MySQL. So let's do that. So the only thing we need to do first is head into SQL Pro and create that Birdwatcher database. You can see right here I'm connected, test. Let's go ahead and add a database called Birdwatcher. Now you can see we got MySQL 5.7.13 here. Let's run this. And sure enough, there it is, 5.7.13. So we've got the connection, we're good to go. Let's delete this. So now we need to tell MySQL and we need to tell the droplet about our citing because we want to use this MySQL database to store it. Well, in a lot of other web frameworks, you might make a migration and you might go and you might code that migration yourself. You give it an up, down. So you say when it's up, I want to create a citings table. I want to make an ID column, a string column for the bird name, an integer column for the time name, all of that. You'll also need to code the reverse of that. So when we revert the database, I want to drop the citings table. Well, Vapor is going to take care of all of that for you. So all you do is you say preparations. When we're preparing to run the app, I want you to make sure you're prepared for citing. And I'm just passing the type there. That's what .self does, is I'm passing the type of citing. When Swift 3 drops, you're going to be able to do just this, but for now we have to add that .self in there. So that's all good. Now I'm going to run back over to the CLI so that I can show you this in the CLI. So let's build this. Now, every time you run your application, it's going to make sure it's prepared first, because if you try to fetch your citings from a MySQL database or you try to save some to it, it's going to crash if you don't have those tables, because MySQL is going to throw errors for that if the table isn't there. So every time you run your app, Vapor is going to make sure it's prepared first. But if you don't want to run your app and you just want to run the preparations, well, you can do that. Vapor has in it a bunch of commands you can run itself. So you can serve it, of course, or you can prepare. And you can see we also have that revert feature. So let's run prepare. And you can see preparing citing, prepared, database prepared. Let's go in and let's see what it did. So here's our thing. Let's refresh the tables. There we go. We got a fluent table and a citings table. And you can see that it automatically went in there and it prepared it for that citing that we created. An ID column, the bird, and the time, and they're all the right types to store what we need. Okay. So the next step now is, well, let's save the citing that we created here. So all we have to do is we have to try to save it. And it's going to ask us to just change this to a variable, because when it saves it, it's going to go back in and it's going to change the ID on the sighting. So it wants to make sure that this is something mutable. Okay, so let's run that. And you can see down here, it says database prepared. It didn't run anything, but now that we do have preparations in our droplet init method, it's going to make sure that the database is prepared every single time. So let's go over to rested, and let's try to save the sparrow. Now you can see this time I got the sparrow, but I also got an ID back, and that's good. So if we go over to SQL Pro, look in our table, there we go, we got a sparrow. Let's try again just to test. Okay, ID 2, and there we go. And it's putting the time in and everything and turning it into JSON for us. Okay, so this is great, but I see one potential issue with our API, and that's that you could come in here and say, you know, dog. Okay, well, you just cited a dog, and it just saved it to the database, so that's no good. So let's go ahead and let's test doing a database reversion so we can get rid of that dog in there. So prepare revert. And it's going to ask you, are you sure you want to revert it? Well, I can put yes or no in here, but it's using a really cool API, so we can actually just, it'll keep asking no matter what we type until we get that yes or the no. So it's a very robust console interface here. So yes, we want to revert the database. OK, so it's reverted. So let's kill this. Now let's go in here and let's add in some code to talk to that Cornell Ornithology API. And they're going to tell us whether or not this is a real bird. Whoop. There we go. So this is going to query the ebird.org taxon with the query of our bird name using the drops client. So we automatically make a client for you that you can use. It's an HTTP client. It also supports SSL and TLS. And then we're going to look through that response data. So we're going to take the first item. Now, this is something crazy. This is something that you would never do in another language because you would be scared of index out of bounds. You would never just directly access an array here putting an index, because if the array includes 0 items and you try to get the 0th, which is the first item, that's going to crash your application. That's probably going to give you a 500. But Swift doesn't let you do anything unsafe like that. So we're totally fine to come in here, say we want the first item and we want to get the name of that item as a string. And if we can't find that, we're just going to say bird was not found. OK, so let's run that. You can see I ran the app and I had reverted previously, so it's going to prepare the database again, and now the database is going to be empty. So that's a really fast way to go through and make even modifications to your model, modifications to your data, and just keep programming and not have to worry about fixing your migrations, which can be really a pain. So let's head over to rested and let's try to spam it with this dog again. Oh, bird dog was not found. OK, well, let's do a real bird. Let's do a parrot. There we go. It works. Perfect. OK, so let's move on to the next step here. So now we want to be able to get an individual sighting back. So if you do, and I'll show you kind of what the API for this should look like. If we go to settings, sightings 1 here, and we do a get, then since this ID is 1, we should expect to get that back. So let's make that happen. So let's go in here, drop.get sightings. And in most other web frameworks here, you would do something like, you know, ID, and then you would go down and you would say, let's just simulate what this would look like. You would grab out of there like something like request parameters, ID, and you would grab it out, and you would have to make sure that this name matches this name, and then you would have to cast it to an integer maybe, since this is going to be an integer. Well, Vapor is going to take care of all of that for you. All you're going to do here is you're going to delete this, and you're going to pass comma int.self. And that's going to make sure that what you're getting back here is an integer. And then it's going to give to your closure that integer, which you can call anything. And you can see that, let's return something first. Let's return this integer. OK. And you can see that this is going to give a request and whatever type is there. So let's return that. And let's test this out. So we do get 1, and it returns 1. Let's try 2, 3. It works perfectly. So now we need to go and we need to fetch the citing with this name. Well, since Vapor is using protocols, and this is really anything that you see is string initializable, any type that can be initialized with a string can be passed here. Int is that by default. String is that by default. Well, also anything that conforms to a model is that by default. I apologize if you can hear the sirens outside. That's what happens when you live in New York. Hopefully that's not too annoying. Okay, you can pass a citing in there. I'm so sorry. I was going to say something at the beginning of the talk, but then I was like, what are the chances that we would have an ambulance stuck outside of my door? Okay, I'm going to mute this for a second and keep coding so I don't deafen you guys. Okay, hopefully it's less prominent now. So you can see what I've done here is I just swapped that out. So instead of an int, I said, I want to get a citing with this. And I passed it in here, and I'm returning it here. So let's see what happens. So let's pop over to rested, and there we go. It just returned, it automatically went, fetched our database for the citing with an ID of 1, and returned it as JSON just automatically. Okay, so let's see. Okay, so now let's figure out how many times we've seen one of these birds. So if you call drop.get sightings, and we want that citing again, but then if you put count after that, we're going to return you how many times you've seen this bird. So let's just pop this code in here. So all this is going to do is it's going to say sightings. It's going to filter where the bird is the same name as whatever bird they gave us. So it's going to search through the database, and then it's going to return the count. So let's try that out. Count, and we've seen a parrot once. And if we go through to sightings and we post another parrot, and we come over and we ask for the count on this, 2, perfect. Okay. So now you can see that this is getting a little busy in this main.swift file. So let's go ahead and create a controller, which is going to hold all of this stuff for us. Okay. Okay, perfect. So you can see what I did here is I moved the creation method to a thing called store. I moved the count.method down here, and I added the show method and the index method. So basically everything that we're doing here is very traditional REST resource based. So we can actually just move that directly into a model, and it's going to know when you index, that's get on /sightings. When you show, that's get on /sightings / the identifier, etc. So now I can just come in here, and I can add, I can create my resource. So I'm going to call it sightings equals sightings controller, and I'm going to pass it that drop in case I need it. And then I'm going to say drop.resource sightings is going to be that sightings. And I can also do a custom call to it. This is going to do all of the default REST methods, but that count one is not really a default method. So I'm going to have to return that manually here. Okay, there we go. And let's make sure everything still works. Count works, getting an individual one works, and now we have this index method where it shows us all of our sightings. Okay, perfect. So now we have the API working. Well, let's make the website. So normally what you would do here is you would make a separate project for a website, or you would create a JavaScript front end or something. But since Vapor is so dynamic, what we can actually do is we can, for the same route, so if you get this, back down here, sightings. If you get this in a JSON client, so something that accepts JSON, which is indicated by this, then we want to give you back JSON. But if you go over to Safari, and let's demo this, it's also going to give you JSON right now. But that's not as useful if you are a Birdwatcher and you don't know what an API is. So let's make a nicer page for them. So I'm going to go a little fast here since we only have a few minutes left, and I think we could do 10 minutes of questions since I have so much to show you here. Yes, this is being recorded. Someone asked if it's being recorded. Okay, so let's go through here and let's add on citing. I'm just going to add a couple of convenience methods here. Computed properties for turning that time into something a little bit more readable, because Birdwatchers don't really know what Unix timestamps are. And then let's go down here. And this is something really cool that I'm going to add here. So what I'm adding here on response. So this is on Vapor's response, but, oh, thank you. Okay. This is on Vapor's response object here, and I'm extending it. So what I'm saying here is I'm saying I'm adding a new property citing and a new property sightings onto Vapor's response. And you're going to see what we're going to do with this in a second. But I just want to show how extensible and how customizable everything in Vapor is, because it's Swift. You can extend onto any class. You can build onto any class. So what I'm going to do here is what's happening behind the scenes when we return one of these sightings objects in one of those route closures. It's calling make response. And so normally that's going to make a JSON response for you just by default for your models, which is what we wanted. But now we want to do something a little bit more custom. So in the make response method for citing, I want to just create a response. I want to set this citing on the response, then I want to return it. And that's not going to do anything right now, but using middleware, we can inject middleware into our app that is going to negotiate this, whether it's a JSON API or whether it's a website, a browser request. And this is kind of something new that a lot of frameworks can't do because they just can't be this dynamic as the Swift language is. And I'm also going to add in a custom make JSON method here. So I'm going to override the default one because I want to include the readable date in our API. And you know what? Let's also just include the Unix timestamp. Okay, and then I'm also going to do on here. So this is going to make the response, this method here, for a single citing. But what happens if I have an array of sightings? Well, I can extend any sequence. So if you have a collection, you have a lazy sequence, you have any sort of an iterator, anything that's holding sightings, you can turn this into a response now. So whether you're doing array slices, anything, any of those advanced language features, this can work for you. So in this situation, I'm going to put on response sightings an array of the sightings. Okay, perfect. So now let's add in this middleware. Okay. So this middleware might look a little complicated, but once you get to understand them, you're going to find how powerful they are. So it's going to respond to a request, and it's going to chain the next responder. So you can imagine this as a giant link where the request comes in on one side, and they link all the way through to the end person. And we're going to add one of the chains into the middle of this. And what the chain is going to do is the first thing is we don't care about the response or the request. We are only dealing with the response here. So we're just going to immediately get from the previous chain its response. We could come in here and we could make any sort of changes to request we want, but we don't want to. So if the response has a citing and it's using that extension that we added down here. So if we put something into this citing, which we do when we call make response, then it's going to turn that into JSON. And if it has citings, then it's going to map those. It's going to go through each of the citings, turn them into JSON, and then return a JSON array of those. So let's see what this looks like. Oh, first things first, we have to take our middleware and add it to our application. Citing middleware. And we're going to give it this droplet in case we need it. And we're going to call drop.globalMiddleware.append this middleware. And we could do middleware based on a few routes. Like we could say we only want the middleware to run on this. We only want it to run on this. But we're just going to do the global because that's the easiest for now. OK, so let's head back over to Rested. You can see, OK, it's working perfectly. So we have all of this still going. But now this is where it's going to get interesting. So I have the request here. So what I can do if I have the request is I can say, well, if the request accept prefers HTML, so there's a special header that gets sent, and I showed you it a little bit right here. You can see all browsers send this accept, and we're going to parse that out because this is really confusing. What does */* mean? Well, Vapor parses all of that out for you. And we're going to say if the request accept prefers HTML, then we're going to return a view. Otherwise, we're going to return JSON. And inside of this view, what we're saying is I want my drop to create a view. And this is important that the drop be involved here, the droplet, because it knows where your views are located. And by default, that's just the working directory. But if you wanted to run multiple droplets side by side and have their views in different places, you could. So it's going to try to get the citing.mustache. And you can see if we come down into resources views, we have that citing.mustache file. And I can show you that. It's just going to go through. It's going to grab some stuff and iterate over the bird in the citing. And we're just going to say these are the two things it needs. It needs the ID of the citing and it needs the bird because it's going to use those inside of the mustache template. So we're going to do that for an individual citing, and we're also going to do that for multiple citings. So if it's multiple citings, we're going to do the citings with an s.mustache file, and we're going to give it an array of all of these. This is just some formatting. The citing only needs the ID, the bird, and the date for our web interface. So we're just going to add mustache to our project now because mustache doesn't come with Vapor by default. It might in the future, but for now we want to keep it lean. Okay, let's add this in here. So exactly the same as how MySQL work. We call Vapor mustache provider. But the way that the Vapor mustache initializes is different because it obviously doesn't need a host or a user. It wants to know what kinds of includes that you have. And we have a header and a footer include, and it's going to cache those so that if you have a lot of includes and they're loading on the page, it's very, very fast. OK. And now we're going to go ahead and add in those providers right there. Let's hit run. OK. Let's head over to Rested. OK, so everything's still working normally for us over here in our API. But let's head on over here and let's see if anything has changed with the citings. Ooh, interesting. Oh, 1 second here. I just have to call .make response here instead. OK. What did I type wrong? Oh, one extra. OK. And then let's get rid of that JSON because it's going to automatically convert that to either a view or JSON, depending on what the browser wants. Okay, let's head over into Safari again, refresh. And now you can see we got a website, whereas over here, for that same thing, we get JSON. So I think that's pretty cool, and I think that's going to kind of change what websites do in the future, because now all of this code that would be duplicated between your API, your website, can just be put in middleware and kind of be decoupled from all of that. So your logic is your logic, and your views are your views. So you can see we have a parrot in here. Let's go add one more API route really fast that is going to get the images of the bird from Cornell's Ornithology API. So this is going to go through. It's going to, when we call images, it's going to get the bird name from the images. It's going to go to the Ornithology API catalog, and then it's going to loop through the results, give us the preview images, and there we go. So let's run that. And if we go over to Safari and we click on parrot, there we go. We got some awesome parrot pictures over here. We can see we have 2 sightings of parrot. Let's try putting in a sparrow. Let's try putting in a dog. Oh, wait, dog doesn't work. Perfect. And now let's do, how about a swift bird? And let's say we've seen swift a few times today, so let's put that in. There we go, 3 sightings of the swift bird. Oh my gosh, that one looks exactly like the logo. Okay, perfect. So that is how you make a web service in Swift with the API. We're going to be hosting all of this code online so you can look through it. But I do want to give you guys just one more thing, a sneak preview of something we've been working on here. This isn't available to the public quite yet. It's doable, but we're going to be making it very easy in the future. So some of you are probably iOS engineers here, so this is going to look familiar to you. This is an iOS interface here. But you can see what I'm doing here is I'm importing Vapor. So this is an iOS app, but I'm importing Vapor. Now, why would I do that? Well, I can use the same client that I used to talk to Cornell's Ornithology API, and I can use that to talk to my bird sighting API. So now I'm using the same code on the server that I'm using on the client. And not only does this make things a lot easier to get right in my head as I'm programming, but in the future, if you have the same thing on both ends, you're going to be able to get some very cool features. So let's go ahead and let's build this app. I've got my simulator over here. And there we go. We got our 3 swift birds, our sparrow, our parrot. Let's go ahead and let's toss in an ostrich just for fun. And just to see if we can, let's put that dog in there. Okay, we can't. Still can't put that dog. Okay. Let's head over to Safari, go back to this page, refresh, and there's the ostrich we just put in the iOS app. They're very interesting looking birds. Okay, so with that, we've got about 10 minutes left for questions. So let me go through. I have a couple more slides. Okay, so that was the demo. I hope that you guys kind of saw that Vapor is really beautifully simple and elegant, and it's creating a new way to make your web apps and make your web services. And Swift provides a lot of different and new forms of dynamic programming and extensible programming that allow you to make web applications unlike really you could in PHP or any of those languages that are out there. And not only is it simple and elegant and it lets you write less code, do more with less code, but it's fast. As paper that an article that we just released, we benchmarked all of the top frameworks out there. You can see you've probably heard of all the guys up here. We've got Rails, Laravel, Lumen, Django, Flask. Nancy you might not have heard of, but it's a very awesome project. C++, so very fast. That compiles down to assembly as well. Spring, Express, Vapor, and Go. We benchmarked all of these together. We brought in professionals from all of the individual frameworks to set them up to try to make sure that they were going as fast as they can. And Vapor just killed it. The only thing faster than Vapor was Go, which actually doesn't even count as a web framework because it was just using the language, purely the language. So we're really proud of those results. And we think that as Vapor continues to mature and as the Swift 3 continues to mature and actually starts getting optimized, right now they're just in the development phase, that we have the opportunity to dethrone Go on that chart. So that's that. If you want to reach out to us, of course, Google Vapor Swift. That's going to be the easiest way to find us. http://qtheory.io is the website. You can get to the documentation, which I didn't really have a chance to talk about, but the documentation is great. We've got almost every feature well documented in there with examples, everything. You can talk to us on Twitter @qtheory, and if you're going to tweet about it, #VaporSwift. So now if you guys have any questions, let's go over those. Okay, so we have a question from Jay. Can you compare the productivity level of Vapors to Rails or Sails or Loopback? So I know about Rails. I don't quite know Sails or Loopback. I've been a web developer for probably 7 or 8 years using mostly PHP and a little bit of JavaScript and Express. I think Laravel and Rails have some similarities there in terms of they are, in terms of how they use controllers and resources and active record, things like that. I think that Vapor and Swift in general is going to be much more productive than any of those because the compiler is there with you. And you can saw I got one bug during the presentation and that I immediately knew where the bug was. I tried to hit run and it wouldn't even compile for me. If this were a Rails app or a PHP Laravel app, I would have been digging through the source code. You know, sometimes PHP doesn't even show you where the error is if it's not configured correctly. So the great part about Vapor and Swift in general is that if you get it to compile, you know it's going to work. As long as there's not some huge flaw in your logic, if you get it to compile, you know that Vapor and the Swift compiler have checked everything, double, triple checked for you, that all of the values are going to be there as you need them. So it makes programming, it turns programming from the typical, in web development at least, you know, type something, save, go to the browser. It doesn't work. Type something, save, go to the browser. It doesn't work. Type something, and then you go and then it works. It's just programming, developing your app, run, and then you go to the browser and it works. It really changes web development. Okay, Jay lives in NYC also wants to know if there are any Swift meetups that I would recommend. Yes, Brooklyn Swift is awesome. That's the only one I've been to so far, but I would highly recommend going to that. They're really cool guys. Can you host it? Someone asks. Yes, you can host this. This runs on Linux, Ubuntu 14.04, 15.10, Heroku, Docker, whatever you can name, this is going to run on it. And the Vapor CLI is going to help you push to Heroku immediately. Docker, you can do it all right from the command line. And we take care of making sure that the Swift language is there and ready to go. It's really fast. We use it all the time. Okay, I have done some work with APIs. However, I'm trying to get better at network requests, server-side stuff. Where do you think I should start? So exactly, this is a huge majority of iOS developers, which I was also an iOS developer, who want to start getting into the backend, and also vice versa, the backend guys wanting to get into iOS. So where should you start? Create a simple app. Create, obviously, you know iOS well. Create your iOS app and try to make the backend for it. Instead of using CloudKit, try to make a backend that could work with Android, Windows Phone, a website, and your iOS app. And then also, like I just showed you, you can import Vapor into your iOS app and use it there instead of something like Alamofire. So now on both sides of the equation, or Alamofire, you're using the same code and you can expect it to work beautifully. Someone asked, do you need an OS X server, Mac OS server? No, you do not. This runs on Linux. Mac OS, iOS, tvOS, watchOS, and potentially Windows in the future and Android in the future. They've made an Android compiler now for Swift. So this has the potential to be your go-to framework for really any platform. Thank you. I or L says, amazing that you could do this in 50 minutes, real-time coding and QA. That's the power of Swift. I'm telling you, you've got to try it. It's going to reduce your development time by an order of magnitude. Yep, someone's asking for contact information. qtheory.io, it's right on the screen here. If you go to the GitHub, linked from that, you have contact information for all of the developers that work on there. If you join our Slack, we're always online, and we love to help people out who are trying to build apps with Vapor or Swift in general. Okay, I think that's my time. Any last questions from anyone? Okay, thank you guys. Have a good rest of your day.